All right, empirical rule. This video might get kind of lengthy, so just stay with me. You just watched a video and it talked about normal distributions. Well, for empirical rule to work, it has to be a normal curve. Okay, so our data needs to fit an approximately normal curve here. All right, well, the thing about a normal curve is your mean is right in the middle of our data. All right, and that means 50% of our data is above the mean, 50% of our data is below the mean, okay? So here's what empirical rule tells us. Within one standard deviation of the mean, so one standard deviation right, one standard deviation left, there is 68% of our data. Within two standard deviations, there's 95% of our data. Within three standard deviations, 99.7% of our data. Okay, so you need to know those figures. Those are some things that you're going to have to know and recall for tests and quizzes and different things like that. So 68, 95, and 99.7, 1, 2, 3 standard deviations. So here's how the breakdown kind of goes. So if we're looking at our normal curve, we know we've got our mean in the middle. Yes, I know I'm an artist, so make sure your picture looks just as good as mine. And we're going to do 3 standard deviations on each side. So this is positive 1 standard deviation, 2 standard deviations, 3 standard deviations, -1, -2, and -3. And they're negative because they're on the left side of the mean, positive because they're on the right side of the mean. Okay? Well, look at it this way. Between here and here is 68% of our data. But it's also split into 2 equal regions, which means this is 34% and that is 34%. Okay, 68 divided by 2. Between between 2 standard deviations is 95% of my data. So we've already taken up 68%. So between these 2 places is 95 minus 68, which gives us 27% of our data. So 27% of our data is split between those 2 locations, which means if I take 27 and divide it by 2, because there's 2 equal regions, I get 13.5% of my data in each one of these areas. Now, in between 3 standard deviations, 99.7% of our data. But again, we've already used 95% of our data up there. Okay, so we take the 99.7, subtract the 95. That gives me 4.7% of my data in these 2 regions. A very, very small piece, but still 4.7%. There's 2 equal regions, so again, we're going to take this and divide it by 2. And that gives me 2.35% of my data. Now, that's only 99.7%, which means there's a little bit left over. Way out here, outside of 3 standard deviations, there's only 0.3% of my data left. Okay? Take that, divide it by 2, because there's 2 equal regions, 1 on each side. That gives me 0.15% of my data. So this is 0.15, and this is 0.15. Now, this you need to write down, keep it in your notebook. You need to know how to come up with those percentages underneath the curve. So every time you do one of these problems, practice it. Write it down. So let's look at what a problem is actually going to look like. They might tell you something along the lines that we have 1,500 students taking the ACT. They might tell you the mean is going to be for this year 24 with a standard deviation of 3.5. Okay, I don't know, all fictional numbers. So that's everything they're going to tell you, and then they're going to ask you a lot of questions. So what we're going to have to do is we're going to draw our curve. You're going to split it into the different regions. Now, put your percentages in. So this gets a 34, 13.5, 2.35, 0.15. And then you do the same thing back out the other side. These are the numbers that you need to memorize that I just showed you how we got those. Now, we have all those pieces. Everything's there. The mean goes in the middle. That's a 24. Okay? Now, the standard deviations. Going this way, we're adding because it's a positive side. So this means this line's a 27.5 because that's one standard deviation. Add another 3.5, we're at 31. Add another 3.5, we're at 34.5. Go the other way, subtract it. So this is 20.5, 17, and then 13.5. Okay, so we have everything labeled. All of my percentages are there. Everything's good. The first question they might ask are scores, percent scores between 17 and 31. Okay, well, that's pretty simple. You block off everything down to 17. You block off everything up to 31, and you simply add it all up. Okay, so 13.5, 34, 34, and 13.5, you add it all up. That means there's 95% of our scores in that range. If they say percent less than 20.5, well, that means less than, means left. So I block off everything else. I add those scores up. And that's going to end up giving me 16%. So that means greater than, let's just say 17. Greater than means measure to the right. So we're going to add up all of these percentages. Okay, so I think you have the idea of how to calculate between, less than, greater than, all those type of things. The only place that you might get it confused if they ask for approximately how many, this is the key word, how many students scored less than a 17. Sorry, I know you can't see that entire thing. How many students scored less than a 17? This is a two-part question. First piece, figure out the percent. So what is the percent less than 17? So we go up to 17, less than means left. So 2.35 plus 0.15 means that is 2.5% of our data. However, they're not asking for percentage anymore. Okay, what they're asking for is how many. So I take my percent, I convert it to a decimal, which is move the decimal twice to the left, fill in any gaps with a 0. 0.025. I take that, I multiply it by the number of students that took the ACT, which in our case was 1,500. So now I'll multiply these two numbers together. It shows me that that was 37.5 students. Well, you can't have half a student, so we end up just saying this is 37 students. So if you end up in a scenario where it's saying approximately how many, first, find the percent. Second, take the percent multiplied by the number of whatever things that you're looking for. Okay, hopefully that helps you figure out empirical rule. Make sure you're drawing this chart every single time. If I'm going to the right, I add. If I'm going to the left, I subtract. The mean always goes in the middle. Add the standard deviation each time. All right, work through the practice worksheet. If you have questions after the practice worksheet, come and find me. I'll be more than happy to go over those with you. All right.